Welcome back, 8th graders. We're at week 7. This is our first lesson of week 7. In the book, we're on page 356 to 357, still in topic 7, still in lesson 2. Let's get started. All right, let's start with a quiz. Winds that blow over a short distance are called A, global winds, B, regional winds, C, wind vanes, or D, local winds. 5, 4, 3, 2, 1. Let's get rid of some answers. Guys, wind vanes are an instrument or tool that we use to measure the direction of winds. Remember, they always have a rooster on top of them? So it's not wind vanes. Let's also get rid of global winds because globe, think of the globe, or excuse me, global, think of a globe. A globe is super big. I don't think if you're a global wind, you're going to blow over a short distance. So correct answer is local winds. And please remember, local winds will only act if global winds are weak. All right, so speaking of global winds, that's actually going to be the goal for today, what we're going to learn about. And global winds are winds that are moving around the globe, and it's at a much larger scale than local winds. Okay, before we get more into global winds, I want to review parts of a globe, just in case you forgot. So I've got on the tippy top the North Pole. Maybe you think Santa lives here, maybe you don't. And if that's the North Pole, the pole on the bottom of the globe is going to be the opposite of north, which is south. So we have the South Pole. That little line that goes around the Earth, that is known as the equator. Okay, so we got our poles and we've got our equator. All right, now let's talk about the Earth and the sun's rays. So I've got Mr. Sun up there. And Mr. Sun, his rays are going to hit the Earth two ways. So it's either going to be direct, which I think of spot on. So that means that the rays are going to hit Earth spot on. And I kind of think of this like a flashlight. Like when I was a little girl, I got in trouble at Girl Scout camp because I took a flashlight and I shined it in a girl's face. And that was really spot on. I was directly on target. I wanted to shine it on her face, so I shined it on her face. But there is another way that Earth's rays can hit Earth, which is called indirect. So indirect, think of off target. So like maybe if I was a little less evil when I was growing up, I would have shined my flashlight on the girl's shoulder or chin or I don't know, just maybe not in her face. So two ways the sun's rays can hit Earth: direct or indirect. Okay, so let's look at our globe again, and now we know our parts of the globe. So let's start with the North Pole. The sunlight is going to hit the North Pole indirectly, so that means it's not quite on target. So if it hits the North Pole indirectly, what do you think it's going to do with the South Pole? It's also going to hit indirectly, and again, that means it's not shining directly, it's a little off target. All right, now the equator, what do you know about the equator? Do places on the equator tend to be warmer or tend to be colder? Hopefully you said warmer, and one of the reasons why they're warmer is because they're getting direct sunlight, so it is shining right on those countries, right on those places that are on the equator or close by. Okay, I need you to remember that warm air creates low pressure, and you're probably going to get warm air if you're in direct sunlight. So what part of the globe do you think has low pressure? All right, hopefully you said that there's low pressure at the equator, meaning that there's high pressure at the poles because they're going to be colder because they're not getting direct sunlight, they're getting indirect sunlight. All right, and these differences in pressure, I've got high pressure at the poles, low pressure at the equator, is going to create winds, specifically global winds, because it's at a much bigger scale. Okay, so let's see how these winds are going to move across the globe. So remember, there is a pressure difference between the poles and the equator. The poles are at high pressure, the equator is at low pressure. Because of this difference, the wind is going to blow from the poles to the equator. Why? Remember our life lesson. High to low. High to low is the way to go. High to low is the way the wind will blow. So let's see this. From the poles to the equator. We'll learn about high elevation later. Maybe you should write this on a piece of paper. All right, I'm done. Okay, so that's simple enough, but what about if we are up really high in the sky because we're on a mountain, or I don't know, where else would we be if we were on a mountain, a really, really big ladder? Okay, anyways, focus, Miss Stowski. Okay, so if we are higher in the atmosphere, like on a mountain, or we're just some wind that's chilling up real high in the atmosphere, we are actually going to do the opposite. So we are going to flow from the equator to the poles, but only if we're at high altitude. So I just talked about the patterns of the wind on the globe, and it's really easy for us to understand global wind on a flat model of Earth, but the Earth is round, it's not flat, it's also on a tilt, and it rotates. So this is going to change the wind patterns. So what's going to happen is, because the Earth is curved and spinning, the winds are going to be curved too. And this is known as the Coriolis effect. Let's take a look at the results of the Coriolis effect. So again, this is going to make curved winds. So they're not going to flow directly in a straight line. You know, I love me a good GIF. And I really like this merry-go-round on a playground, because if you look from the top, you see that the kids are sitting directly across from each other. So like in a straight line, I can draw from the yellow shirt to the green shirt, from the blue shirt to the red shirt. All right, so a merry-go-round is spinning, and what those kids are going to do is they're just going to try to pass it to the person directly across from them. But you see, as they try to pass it, because they are spinning, that ball isn't going in a straight line. It is curving. So when blue shirt tries to pass the red shirt, it actually goes to yellow shirt because of that curve. So this is also what happens at the globe with our winds. And I honestly can't look at that GIF anymore because I feel like I've had party too hard on a merry-go-round when I was little, and now I get nauseous when I look at them. Also, tire swings. Blech. All right, refocusing. Again, here's another GIF. Like if we were at the equator and we were going to throw a paper airplane, and we would expect this would go from the top of South America to the bottom of South America in a straight line. But as you see, it's curving because the Earth is spinning. Okay, so what happens because of this? Well, in the northern hemisphere, winds curve to the right. And in the southern hemisphere, it's going to be the opposite. So they are going to curve to the left. All right, we are almost at the finish line. Let's end with a little quiz. High air pressure is usually found at the A, equator, B, equator and the South Pole, C, the North Pole only, or D, both poles. 5, 4, 3, 2, 1. I'm going to take away the equator because the equator gets direct sunlight or spot-on sunlight, and that makes the temperature warmer. Warmer air has low pressure. So then I also have to eliminate B because the equator is always going to be at low pressure. So the correct answer is both poles, okay? It's not just north, it's not just south. Okay, guys, that is it. Have a good rest of the day, and I will see you back here soon.